to my YouTube channel. I am Hajra Mughal and today we will be continuing our lecture series on MDCAT and ECAT preparation for physics. I am glad you are joining me and I look forward to helping you achieve your academic goals. Let's begin. So students, today we will be focusing on the topic of waves, tackling multiple choice questions to test your understanding and help you feel confident for the exams. To excel in multiple choice questions on this topic, waves, it's essential to review the following key concepts like waves and its types, progressive waves, periodic waves, transverse, longitudinal waves, speed of sound in air, Newton's formula for a speed of sound, Laplace correction for a speed of sound, factors affecting speed of sound in air, superposition, interference of sound wave, stationary waves, interference in stationary waves, harmonics, Doppler's effect, characteristics of simple harmonic motion. Waves produced on the surface of water in a lake are transverse wave, longitudinal waves, stationary waves, all of these. So students, let's recall one thing, that what is transverse, what is the difference between transverse and longitudinal wave. So students, remember that transverse wave are those which moves perpendicular to the direction of propagation, okay, and the longitudinal waves are those which moves parallel to the direction of propagation. There is one more difference, that transverse wave makes crust and trough and longitudinal waves makes compression and rarefactions. So students, transverse waves have the particles that is oscillating perpendicular to the direction of wave propagation. In water waves, the water molecules move up and down, creating a disturbance that travels horizontally across the surface. This up and down motion is perpendicular to the direction of propagation. That's why we call it as transverse wave. So the correct option is A. Okay, so next MCQ is, at what temperature the velocity of sound is 3 times its velocity at 20 degrees C. So there is a given condition that velocity of sound at what temperature, you have to find this temperature, okay? So the velocity of sound is 3 times the velocity at 20 degrees C. If I rewrite this equation, then the ratio of these two velocities is equivalent to 3. So you have to one temperature, let's say that is unknown, and one temperature is given to you which is 20 degrees C, and if you convert it into Kelvin, then you have to add 273, then it will become 293 Kelvin. So students, if you recall your previous knowledge, then the formula is the ratio of the velocities is equivalent to the under root ratio of the temperatures, okay? So if I remove this side, then it is equivalent to 3, that is the given condition, then it is equivalent to 3. So taking a square on both sides, so T over 293 is equivalent to 9, and if you multiply these two, so 293 multiplied by 9, 3 9s are 27, 9 9s are 81, 82 and 83, 2 9s are 18, and when you add 8, then it will become 22637. So correct option is C. Okay, so students, if the density of a gas is doubled, density of the gas is double the previous one, the new one is represented with rho prime, and other parameters are constant, then sound velocity becomes dash times. Okay, so students, if you recall your knowledge, then you must have studied this formula of velocity of sound, gamma p over rho. This is the formula which Laplace has given. So if you have doubled the density, so gamma p over 2 rho, and if I take 1 over under root 2 on the other side and gamma p over rho separately, then it is the formula of velocity again. So the new velocity is 1 over under root 2 times the previous one. So the correct option is 1 over under root 2. Okay, so which of the following is not transported by waves? And the options are energy, disturbance, matter, and all of these. So it's a very easy MCQ, and it is understood that matter is not transported by waves. You can think of it like a crowd doing the wave at a stadium. People stand up and sit down, passing the energy of the wave along, but they don't actually move their location. Similarly, waves transfer energy, not matter. Two waves having wavelength of 0.5 centimeter, wavelength of 0.5 centimeter interfere constructively. Okay, find the path difference considering three waves motion. Okay, so the number of waves are given 3 and they are interfering constructively. So we know that, students, the path difference for constructive interference is n lambda. So n is 3 and lambda is 0.5. When you multiply it, it will become 1.5 centimeters. So the correct option is B. Speed of sound in vacuum is, so students, remember that sound require medium to travel. So the speed of sound in vacuum is 0. Okay, so students, next MCQ is a string firmly held between two supports is plugged from 1/4 of its length to produce stationary waves. Okay, so students, look at here. It's a support and it's a string of length L, as they have given that the length of the string is L. Okay, and this is the center of the string and it's 1/4 of the string. So if a string firmly held between two supports is plugged from 1/4 of its length to produce 2 loops of stationary waves. So remember that whenever a string is plugged from 1/4, so it will vibrate in 2 loops, and 2 loops means it's half of the wavelength and it's one more half of the wavelength. So it's lambda by 2 and it is also the lambda by 2. And what you have to calculate? You have to calculate the wavelength. So the whole length is equivalent to the sum of the lambda by 2. So when you solve it, so it will be equivalent to lambda. So lambda is equivalent to L. It means that the wavelength is equivalent to the length of the string. And I have highlighted it. So it means that this question has been asked in previous years as the question of MDCAT. Time period in wavelength of a wave are 2 seconds and 30 centimeters. So the time is 2 seconds and the wavelength is 30 centimeter. When I convert it into meters, so it will be 0.3 meter, and you have to find the speed in meter per second. Okay, so how we are going to do that? The formula of the speed is meter per second, so wavelength per unit time, so it will be 0.3 meter, and 2 seconds, so unit is correct. Okay, how we are going to solve this? If I remove this decimal, so it will be 2 into 10 and 2 into 10 will become 20. So if I divide 3 by 20, so I will put point over here, so it will give me a 0. So 20 ones 20, so 10 is remaining again because I have already put a decimal, so I can take 0 over here. So 25 is 100. So the correct option is 0.15. So students, next MCQ is echo is produced by reflection of sound wave from denser medium. What is the phase change between sound wave and echo? So students, remember that a sound wave travels through a medium, for example like air, and hits a denser medium like a wall. So the sound wave is reflected back, creating an echo. During reflection, the sound waves phase is reversed by 180 degrees, this means that the compression becomes rarefactions and vice versa. So the correct option is option number C, the phase reversal of 180 degrees. Okay, so students, next MCQ is, in which of the medium the speed of sound is maximum? Gas, water, solid, both B and C. So students, remember that speed of sound is maximum in solids because closed particles respond more and quickly to sound waves. You can also say that high modulus of elasticity. So the correct option is solid. Next MCQ is, there are two pipes A and B of same length with both ends open and one end closed respectively. What is the ratio of their fundamental frequency? Students, so this is the MCQ from the topic of organ pipe, and they have given you the condition that there are two pipes having the same length, one pipe having both ends open and other pipe having one end closed. So what is the ratio of their fundamental frequency? So students, I will share detailed notes of this topic with you too. Here is a screenshot from my notes. The fundamental frequency of the organ pipe having one end closed and one open. So the fundamental frequency is V over 4L. And the fundamental frequency when the both ends are open, so the frequency is V over 2L. So you have to take ratio of both end open with one end closed. So if I take ratio of V over 2L over V over 4L, so I can write it like V over 2L into 4L over V, and V cancel out L with the L and 2 with the 4, so the answer will be 2. So the correct option is B. Okay, so students, next MCQ is, what is the fundamental frequency of an open end air column? You have to find the fundamental frequency, and the length is given as 34 centimeter, and if you convert it into meters, so it will be 0.34 meter. Take the speed of sound in air to be 340 meter per second. So from the previous MCQ, we have just recalled that the fundamental frequency for open organ pipe is V upon 2L, and the V is 340 and 2 into 0.34. If I remove this decimal from here, so we are going to have 100 over here. Okay, so 34 ones are 34, 34 ones are 34 and 0. And when I will rewrite it again so to minimize the confusion. So when you solve 2 into 10, so it will be 5, and 5 into 100 will become 500 Hertz. So the frequency is 500 Hertz. Okay, a pendulum of length L performs simple harmonic motion with frequency F. How must the length be changed to increase the frequency to 2F? So students, the formula for the time period of the simple pendulum is 2 pi under root L over G. And we know that the time period in frequency are reciprocal to each other. So the formula for the frequency of simple pendulum will become this. And if you want to twice the frequency, so they are asking how much length should be, what should be the change in the length. So first thing is you can see from the formula that frequency and the length are reciprocal to each other. If you want to increase the frequency, then length must be decreased. So these two options cannot be the answer. It can be B or D. So if I substitute, for example, L by 4, so we can solve it. For example, F is equivalent to 1 over 2 pi under root G over, and if the length is reduced to L by 4, and the new frequency will become F prime. And if I rewrite this formula like under root G over L, and if I take if I write 4, so 4 will be here, and if I take 4 out of the under root, so it will look like 1 over 2 pi under root G over L, and the 2 is out of the formula. So this is the formula of frequency again. So frequency will be increased twice if you decrease the length by L by 4. So B is the correct option. Displacement of vertical mass spring system executing SHM at any instant will be maximum when phase angle is. So they are asking this condition, that when will be the displacement must be equivalent to the maximum displacement, means you can say its amplitude. So the formula is x equal to x naught sine theta. So they are asking what should be this phase angle when they both are equal to each other. So we know that sine theta, sine is maximum at 90 degrees. It gives one answer. So sine 90 is 1. So at 90 degrees the displacement of that particular vertical mass spring system at any instant will be maximum. So the correct option is 90 degrees. Students, we still have many MCQs to cover and I'll be sharing them with you. Thanks for tuning in. Don't forget to subscribe to my channel and click the notification bell to stay updated on our latest content. In our next video, we will be tackling multiple choice questions on thermodynamics as part of our ongoing series. Stay tuned for more.